In our last video, we talked a little bit about building objects. We used a card and a deck of cards as an example for how we could build things, but we did a few things there that maybe weren't the best way to approach the problem. One of the things that we worry about in programming is something called abstraction and encapsulation. Now, when we use abstraction, basically we're trying to take complicated things and make them appear much more simple. When we talk about encapsulation, we're trying to protect all of the data that an object might have so that we don't do things like set the wrong values. So let's go ahead and open up our card object. We've got our class, we were looking into our definition, and we have these public static final ints, which are okay because they're defining constants for cards, but we have this public int rank and public int suit. And this might not be perfect because what might happen, someone who's using our card might set the rank to, say, something like 22, and they might set the suit to something that is maybe not legal, like -5 or 5,000. So we want to prevent people from doing that. So typically what we do when we're building objects, we make our data private. And what private means is that nobody outside of this class, no other objects, no other objects we're working with can actually directly modify these. So when we create a card, we can actually set the suit and the rank, and then those actually can't change, which is actually pretty good. We call that immutability. Lots of objects in Java are immutable, and that just basically means that once they're created, they can't be modified further. But we might want to still provide access to those values. So what we might do is write a method, public int getRank, and all that's going to do is return our rank. And we'll do the same thing for suit, public int getSuit. And because we've done this, we'll go ahead and return suit, and we'll write that out. And because we've done this now, our card is actually encapsulated. No other objects can modify the value of rank and suit. If we wanted to actually provide access to the rank and suit so that they could be modified, we could do something like this. Public void, so we're creating a public method that's accessible to other objects. We're going to return nothing here, and we're going to call this setRank. And one of the things we might want to do in the setRank method is check to make sure that the rank is valid. So we know that our rank should be somewhere between 1 and 13. So if new rank is less than 1 or new rank is greater than 13, we're going to do something here. It's a new concept. We've talked about exceptions. We're going to throw a new illegal argument exception. Rank should be between 1 and 13. Then down after we've done that, we're going to say this dot rank is equal to new rank. We'll go ahead, write that out, and we'll save that. So now we have the ability to set the rank, and we can create just a simple test program to test this out. Let's go ahead and try to compile our card. And we don't have a test program yet. Let's go ahead and write nano test card.java. So we'll say public class test card, public static void main string arguments. And in this, we'll just do something very basic. Card is equal to new card, and we'll say that this is going to be 2 and 2. And then we'll say system.out.println, the card is card, and we've already implemented the toString method. If you remember, in our card method, we implemented a toString method that will allow us to convert this to a string so that when we output this, let's go ahead and just test it. Javac test card.java, Java test card. Card is 2 of diamonds. So you can see here that much is working. Let's go ahead and, just to make things a little bit more legitimate, we'll say card.hearts, because we really want to use that kind of notation. We want to identify that we're using hearts instead of just randomly saying 2. Now let's try card.setRank. We'll try to set it to 5,000 because we know that's not legal. System.out.println, the card is card. Now if we compile and we run it, we'll see something interesting. The card is 2 of hearts, and then we get an exception, a legal argument exception. So basically what we're doing here is we're telling Java something's not right, we shouldn't have that value, we don't want to allow that, so we throw an exception, and that actually crashes our program, which is good because we don't want someone to set the rank there. Now you could catch that exception just like we've done in other exercises, But, for now, that actually is something you shouldn't do, so we're going to leave that alone. And you'll notice another thing, we output that the card is 2 of hearts, but then we never make it to that next statement. If we look at our test card, we never make it to the line system.out.println, because when we set rank to 5,000, we actually call it throw the exception there, so our program crashes before this statement even completes. Now let's go back into our card, and we can actually do something that's maybe a little smart here. Instead of making a public void set rank, let's go ahead and make this a private method. We'll say private void set rank, and here we'll say this, instead of saying this dot rank is equal to rank, we'll say this dot set rank rank. So now we're still protecting our data, we're still keeping the object immutable, because no other objects are going to be able to call this set rank method. We can also use private void set suit int new suit, and we can use if new suit is less than or equal to 0 or greater than. Actually, we'll do this one the opposite. We did the last one where we threw the exception. We'll say if it's greater than or equal to 0 and new suit is less than or equal to 3, then we'll say this dot suit is equal to new suit. Else throw new illegal argument exception. Suit should be between 0 and 3. Now notice in our suit, we're really doing a very similar thing to what we're doing in our set rank. When we create this new suit method, it's very similar to the set rank method. We're checking to see if the data is valid before we set the value, but in this case, we're throwing an exception, and if we make it to setting this, we know it's okay. Here we're checking to make sure that we can set it, and then we're throwing the exception. So ultimately, these accomplish the exact same thing, but they're two different ways of writing it. So now we can replace this dot suit with this dot set suit. So there we go. That's just a nice clean implementation of our constructor. Now we write that. Let's go ahead and modify testcard.java, and we'll try to do a couple of things here. So we'll say let's create this card. Let's say card other card is equal to new card card.diamonds. We'll say 14. We'll set the rank to 14. System.out.println, the other card is card. Now we'll write that, we'll exit, we'll compile testcard.java, we'll run testcard, and we'll see. Now when we try to create a card that shouldn't be creatable, something that we shouldn't be able to do, we still get that illegal argument exception. So that allows us to have a lot more control over how we build our objects. And if we know that our objects are okay and we build our programs out of objects, then it really makes us more confident that our programs are going to be okay. Let's go ahead and modify deck to work this way as well. So now we have a public card array cards. Let's make that private. Private card array cards, and we'll say private int top is equal to 0, because no one should really be modifying the deck. This kind of would attract cheaters if we're actually allowing other objects to modify the deck. We want the deck to really have full control over what it's doing here. So we'll create our deck, and we'll create the ability for drawing a card, and we'll go from 0 all the way to the top of our card, or top of our deck. So here we go. Top starts with 0. And you often think of a deck as like the last card would be the top card. Here we're just kind of reversing things. And we have our shuffle method. So any user of this object is able to draw a card. Any user of this object is able to shuffle the deck. But the deck itself, you can't actually manipulate things. All you can really do is take cards off of it. So it protects all of the internals. And that makes this a little bit safer. One of the things we might want to do, though, is we might want to actually create a deck that will allow us to know if the deck is empty. This is a deck that will work really well, but once we get through 52 cards, we're actually going to get an exception once we go past the bounds of the array. So let's go ahead and we'll create another public method. We'll make this a Boolean, and we'll say is empty. And basically all this will do is if card, or if top is less than cards.length, we'll return true. Else return false. So now what will happen is we'll be able to call is empty to determine if this is actually empty. Now, to make this a little bit more complete, in our shuffle, we'll go ahead and set top back to 0. Basically, what our shuffle method is going to do is reset this class. So we're able to shuffle the deck over and over again, restart. Basically that would simulate collecting the cards. We're able to draw and we're able to check to see if this is empty. Now, if we draw a card that on an empty deck, let's go ahead and we'll go ahead and just write a quick test program for this. So let's write this out. Let's type deck test.java. And we already have a deck test from before. So let's go ahead and we'll clear all of this out. We'll just go ahead, cut everything out here, and we'll go ahead and create a new deck. Deck is equal to new deck. And we'll say for int I is equal to 0, I is less than, say, 60, I++, system.out.println deck.draw. So now if we compile deck test, what we'll see is we get all of the cards, and I'll scroll up here. You can see 2 of hearts, 3 of hearts, 4 of hearts. We never shuffled it, so they're all in order. We got hearts, we got clubs, we got diamonds, we have spades. Then when we get to the end, we get an array of index out of bounds exception. So let's go ahead and modify our deck so that we don't do that. Let's say, if we don't have a card, instead of getting an index out of bounds exception, let's return null. Null is a value that basically means no object exists here. So we can go ahead here and we can say, if not, this is empty. Let's go ahead and move all of those inside. And we can say else return null. And we could also say if this is empty, return null, otherwise return drawn card. It's up to you, it's style differences. So this is one way we could do it. We could also change it. So if this is empty, return null, else do these things. So basically accomplishing the same thing here. If this is empty, return null, else return drawn card. So now if we compile deck test, we get all of these null values at the end. Now this looks like we have a mistake because now it looks like we're returning null all of the time. So if this is empty, return null. So see, we made a mistake here. If top is less than cards.length. So it should be if top is greater than or equal to cards.length. So we have that backwards. So now we're basically saying top is bigger than or equal to cards.length. We can also change this around. We could say if, see, we have a flipped bit here, false where it should be true. So we could say if top is less than cards.length, we're not empty. Just a little mistake there, a little logical mistake. But if you follow that, if we have the top, we're not an empty deck if the top is below the number of cards in the deck. So let's go ahead and try again. Java C, deck test.java, Java deck test. And now you can see at the end here we get null. So we can also change our deck test a little bit here. So we can actually say, instead of using a for loop, we could use while not deck is empty, system.out.println deck.draw. So what this will do is continue to draw cards. And if you think about what happens, we call into isEmpty. We're checking to see if the top has gotten to the top of the array. We're looking at the, we're outputting a card every time. So draw is removing one card, essentially advancing that top value. So we're actually iterating through all of the array of the deck without actually having to do that in our program. See how nice and simple this is. You could almost look at these 4 lines of code and just understand this even if you didn't really know a lot about programming. You can say while deck is not empty, draw a card. So let's go ahead and compile that. We'll run it. And here we get the full deck without actually having to output any null values. Now if we just want to see how this shuffles, we could use deck.shuffle here. And now we'll see a random assortment of cards every time. There we go. And every time we call this, you'll see a different setup for the cards, and they're just going to be all over the place. So you can see how they're all kind of mixed together. Not really in too much of an ordering now. So hopefully that explains some of the concepts around creating private and public methods. It talks a little bit more about encapsulation and kind of shows you how you can make more controlled and more abstract programs. And you can use this power of abstraction to kind of make your programs more readable, make your programs more understandable, and then hide that complexity behind other methods. Thanks for watching, and don't forget to practice your coding.